Hello everyone, welcome back for another lesson. In this lesson, we will be talking about potential energy. So what is potential energy? It's the energy that is stored in a substance. Now, there are different ways that we can store energy in a substance. I am showing you three over here. So one is based on the vertical position or height of the object. So indirectly, it's linked to gravity. So if, for example, I hold an object up and I drop it on my toes, well, that's going to hurt, obviously. But why? Because depending on the height at which I was holding the object, well, it has the potential to hurt my toes. So it has energy stored in it based on its vertical position. Another way to store energy is through through bonds in a substance. So the more bonds a substance has, a chemical substance has, the more energy is stored in those bonds. And if those bonds are single, double, triple, they will store a different amount of energy as well. The third way is depending on the size of the nucleus. So it's nuclear energy that we're talking about here. So the bigger the nucleus, the more potential it has to decay, to split apart, right? We talked about fusion, fission, and all these nuclear transformations. So the bigger the nucleus, the more energy is stored in it. The one type of stored energy we are going to look at now is the one that is related to physics. So it's the one over here based on the vertical position or height of the object. So the equation that we will be working with is EP, for potential energy, is equal to the mass of the object. If you recall, I explained that when we talk about physics topics, the mass is expressed in kilograms, so it is the case here. So mass times gravity. So are we on Earth? Are we on the moon? Are we on Mars? The gravitational pull is not the same. So in most cases, obviously, the problems will be taking place on Earth. The value on Earth, you have it over here, is 9.8 Newton, which is the unit of force per kilogram of mass. So it's also dependent on the mass of the object, as I pointed out over here. So G is 9.8 on Earth. If it's anywhere else, the value would be provided to you. So M times G times H, which is the height, the vertical position of the object that we are looking at. Okay, so MGH is equal to EP. So now let's take a look at some practical examples. First question. What is the potential energy of a roller coaster car with a mass of 100 kilograms at a height of 10 meters? Okay, so we have the mass, we have the height. We know this is obviously taking place on Earth, so we know that the gravitational pull is 9.8. So this would be the mathematical setup. Mass times gravity times height. Now, gravity, this is an accepted value. It is not a measurement. So G never enters the analysis of significant figures. So in this case, my answer should have 2 sig figs because of this number over here, which has only 2 digits. So if we do the calculation, we get 9,800 joules, but because we only want to keep 2 digits, we will convert to kilojoules. That's the easiest way. So divided by 1,000, we get 9.8 kilojoules. If you wanted to put 9,800 in scientific notation, you'd be allowed to do that as well, but I think most of you will prefer to just divide by 1,000 to get an answer in kilojoules. That's much simpler. So this is a very straightforward type problem, not very complicated. So let's look at the second one. A box has a mass of 5.8 kilograms. So we have the mass. The box is lifted from the garage floor and placed on a shelf. If the box gains 145 joules of potential energy, EP, how high is the shelf? Before we plug in the numbers, I just want to clarify something. So here, Here it says that the box gains 145 joules of potential energy. So if you're lifting the box, obviously the box is gaining energy. If an object is dropped because it's losing height, it's also losing potential energy. Okay, so it's important to know this because over here, since the box gained 145 joules of energy, my value should be positive. Okay, so you have to watch how things are worded. It could happen that you're going to have a problem where it's asking you how much energy was lost by the object when it fell from a certain height, in which case it kind of implies that the energy at that point would be expressed in your answer as a negative value. Okay, so when an object is lifted, the energy is positive. When the object is coming towards the ground, it's losing that potential energy. Okay? All right, back to our problem. If we put the numbers in the equation, we get the following. 145 joules is equal to 5.8 kilograms times the value of gravity times the height. And if we solve for the height, now before I solve, how many sig figs should I have? 3, 2, and this we don't look at in terms of sig figs. So 2 is the shortest number with 2 digits. My answer should have 2 digits. And the answer is 2.6 meters. Next question. Clara holds a tomato 2 meters above Luciano's head. This is a huge tomato. It weighs 500 grams. Luciano calculates that the potential energy involved in this situation is 16 joules. Do these people live on planet Earth? Okay, so if we replace, we have the height, we have the energy, and we have the mass, but the mass is in grams. We're going to have to convert this to kilograms, right? So 500 grams is half a kilogram. So this divided by 1,000 gives me 0.5. So this is what I get as an equation. I'm solving for g. That's the only value that's missing. And it makes sense because we want to verify if these people live on planet Earth. Now, if this value turns out to be 9.8, yes, they will live, they are human or they live on planet Earth. And if not, then they live somewhere else. So if you do the calc, what do you get? You get 16 Newton per kilogram, which is not 9.8. So obviously they do not live on the planet Earth. They are aliens. So those are your typical problems for potential energy. I hope it was clear. If you have questions, don't be shy, reach out. And otherwise, I will see you for your next lesson. It's the third lesson of 3. It'll be about mechanical energy. So until then, take care.